Alrighty. Hello, everyone. Welcome to the All About Databases pre-hackathon work. My name is Safe. If you guys haven't already, sign up for QSACs at qsacs.github.io. It'll be not this weekend here, but next weekend. Yeah, let's get started. Alright, so starting off, what exactly is a database? Well, imagine an Excel document or any table of some sort, right? And like, let's say you have an Excel sheet and you have it with its own rows and columns. And so, let's say, for example, you have this Excel sheet and it has your schedule on it or something. I mean, there's other softwares for scheduling, but let's say you make it simple with this. And so, on like, this column right here, it could be like the event. This one could be the date. This one could be the time, like other information and stuff. And you organize it like that. And so like these columns are each their own unique information, and these rows are like different like instances. So if you think about a table like that, that's pretty much how a traditional database is organized. It organizes different like kind of data by column and each instance by the row. So what is so good about databases? Why use a database? Well, if you are a software developer, applications rely on data. They're always processing data. They're always pooling data, creating data, writing data, all that stuff. And so databases are a good way to make your app process data. So if you have a database, it'll make your data well organized, depending on what kind of database you have. And then with that organizational structure, you can pull from the database, write to the database, like change data, like filter data, do all that sort of stuff. And it's just a really nice way of handling it. So there are two types of databases that one can use. One is a relational database, which relies on a structured query language. And so this one is pretty much in the title. It's all about relationships. So like when you have different objects or models, you can tie them together with having like one instance fit into like a cell of another table. And then you have your non-relational database, which is pretty much more loose than a relational database. The most common types of data in a non-relational database would be like JSON documents and JSON structured documents. They're also column family stores. I'll get to that in a bit though. So a relational database can be thought of as strictly organized tables with columns that contain references to related tables sometimes. And so you can define a structure of a whole related database system through an entity relationship diagram, which I have here. So right here is just you got three simple models. You got customer, order, and product. And each of them have their own sort of attributes, which you can think of as like columns in their own table or variables or whatever you want to call them. And so big part about it is that each of them have a primary key, which serves as the sort of ID for an instance. And like that ID column stores all the IDs for the instances in your database. So, customer has its own ID, first, last name, other basic information. And then here you have a relationship, which you can see like the way relationships are defined in entity relationship diagrams here. But you have this relationship with order where, let's imagine an Amazon's system. A customer can have multiple orders, which is what's defined by this relationship here. So, but an order can only have one and only one customer. So the order has its own ID, its own primary key, but it also stores the one and only customer that it's linked to, which you can see in this little table right here. So you got three instances, each with their own ID. You got the customer ID, which is stored here, which is basically a reference to the exact customer that it's related to. That's where the relationships come in. Then you have all sorts of other information for the order itself. And so right here is its relationship with products, where, if I were to expand this table, did not mean to do that. There would be, you could have a list of different products that's included in that single order. And so here's the product model too. It's got its own primary key and its own things right there. So that's essentially like a simple structure of a relational database. And so a non-relational database is more loosely organized, usually in the form of JSON documents or column family stores. So JSON is JavaScript's object notation, which is sort of a standard for the way data is structured. So this right here is a simple JSON document. Dictionaries in Python also have this sort of form, where basically you have a key right here and then a value associated with that key. So with this, let's say, dictionary object, you can look up a certain key and it'll return to you the value. So for this instance, for this instance, if you wanted to find the last name of this person, you would look up their last name as the key and then return the value. And here we have a column family store, which is sort of like a table, except it's, like I said, it's very loosely organized. So usually in relational databases, in a table, you define a column as like required, like it has to have a value, or blank or null or whatever you want. So, but here, so like in there, if you have an order and you have to have a customer ID with that order, then you can't have an order that has a blank cell for its customer ID. Whereas here, in this non-relational database, Bob has his age displayed here, but Brittany doesn't. And so it's not required for them to have any of these sort of tables. Like Tori over here, has country and hair color, which none of these guys have. So it's very, very loosely organized. And so comparing the differences between them, when you're dealing with relational databases, you have to define a sort of schema for it, which is where it gets its strict organization. So that's where SQL comes in, where you define your tables and the relationships between them and all that sort of stuff. Whereas non-relational it's pretty relaxed. You don't have to do any of that. Relational is solely table-based, whereas non-relational can have it being document-based. You could have graph databases, key-value pairs, column family stores. And then relational, obviously it's in the name, you can have relationships between data, whereas non-relational doesn't have that. So now I'm going to go into how exactly you can develop with a relational database. So 1 second. I hit the source for a bit. Uh, okay, so there are different types of. I'll make this full screen again. Different types of software that you can use to develop a relational database locally. But the one I use is PostgreSQL. And so if you go online, you install PostgreSQL, you install this application called Postgres Admin, where you can basically manage your database servers and databases locally. And so what you do is you create a server, and then in that server, create a database, and then create a user that you can use for authentication. And so you, in PG Admin, you connect to both the server and the database so that your server is running, it'd be on localhost, and your database would be turned on, essentially. And then what I'm going to show you is a simple Django app demo where you can put your information. So you put the host and port of the server, your username and password, and then the database name in the app settings. So here's Postgres Admin. And so if we look here, we have our servers. So I will connect to this one. And I already set up the information. So as you can see here, the host name and the port is localhost and 5432. And then I'll go over here and I'm going to create a new database. And so I'll call this one demo. And I'll make myself the owner. I already created my user. And you know, you have all these other settings here. You don't have to worry about them. And then save. Then can turn my database on. And so now it should be able to receive requests. So here I have a where'd my mouse go? There it is. Here I have a lot. Right now I'm using VS Code, and here I've built a simple Django demo. And here's my launch file where I define all my environment variables. So here, here's the like kind of like a script with my environment variables in order for me to make a migration, which essentially is a schema. And then should already have that. And then here is where I run my migrations onto the database. So right here, I'll put in the name, demo, which I just created, my username and password, the host and the port for the database. And so if I run my migrations, it should go onto the database that I just created. Also, thank you to whoever's QSACs in chat for helping me out. me try again. Alright, so I was able to migrate all my data, but I think I did not have a migration for it created. Right now it's just migrating all the basic Django apps that I have installed. So create my migration. Also, sorry to all the Twitch viewers for the drop frame. Computer struggling here. Alright, so I've created my migrations. And so basically, in this demo, well, first, what I've done is in my Django settings file, I set up these settings variables to pull from the environment variables and get all this information. And then for my database settings, I put in all the variables so that Django can properly communicate with my app. And then here is just a simple app where I have a customer model, which has its own ID, first name and last name, and then an order model, similar to the example that I showed in the presentation, where it has its own ID, customer name, and then the ship date. So I could have put more detailed variables in my models, but I decided not to. So now that I have ran my migrations onto the database, I can run my test server. And right now in Django, I just have it set up so that my models are in the like built-in admin that it has. And so if I bring back my browser, hi. I'm giving a workshop on databases for QSACs. Alrighty. Yeah, I know. I must have scared her away. So if we connect to one second, I forgot to create a super user. Oops. 1 second. Okay, I should have a user now. I think I forgot to add something to my launch file. Sorry again. Okay. Hopefully this time it works. Okay, so here's the admin site, and here you can see my models that I've created here. So let's go ahead and add a customer. It brings you to this simple form. All I've defined for it is its ID, which is automatically assigned as I defined in my models file, which is just a random UUID. And so give it a nice name. Save that. So now I have a customer object. So if I go back, I can add an order. And here, I created my related field customer. And I don't know why, but that's not appearing on stream. The drop down was it. Anyway, I selected a customer. I can add another one too if I wanted to. Maybe, I don't know. Then I can put in other information. So say the date is today, and then save that. And so now I have an order object, and pretty simple. And I use that all while connecting to my local database. So now all the information is stored in there, and when it looks to see what information is stored in there, it retrieves it, and that's why you can see this now because I created it and saved it to the database. So that is my Postgres Admin demo. So that's just explaining what I did. So now, if you want to deploy, use Google Cloud Platform. I believe they are sponsoring us at the hackathon. Yeah, yeah. So they come to the hackathon. I know, like 2 years ago, they gave out like $50 of free credit, but you can also, when you sign up for it first, you get a free trial for a little bit. You can use your Google account or whatever. So you go to their site and create an account. You use their free trial, and then you create a project, and then they have different services that you can use. And if you're going to be using their database service, you'll probably be using their App Engine service. But for now, we'll just worry about configuring databases. You can even use it while developing. So you can connect to it using the Cloud SQL proxy, which you have to download, and then you can configure all your things in the Google Cloud, but be running it on your own computer for development or testing or whatever. So yeah, so you want to go to the SQL tab and create an instance, and then whitelist your IP address, and then create a database, and then get your connection information from there. So I won't be demoing as in depth as I did with the Postgres demo, but we'll just kind of skim over. So here I have all my stuff, and if I go here, I can navigate to the SQL tab. Then here I already created a test database. If you go to create instance, it'll bring you to this page where it asks you, what kind of engine you want to choose. If you choose Postgres, it'll bring you to this page where you can give it its own name, default user password, and all sorts of other stuff. But now I can view this instance that I already created, and gives me all this nice information. I can view like how much CPU it's using and like all the connections that it's receiving and things like that. And so if you click here, it'll bring you to another page on like the docs for Google Cloud, where it'll explain to you all the different ways you can connect. And you can create your users here. And then since this is just an instance, you want to create databases here, and a bunch of other things you can do. Here's where you whitelist your connection. So if you put in your IP address here, it should be fine. But if I go back to where's my mouse? My Django app. Right, where is it? right here is kind of like the change in settings that happens. So if you are connecting to it on the app engine, you want to put this followed by your instance name, which is right here, and then the port I think is just 5432. You can leave it blank or not even define it. And then if you're connecting with the cloud proxy, then you put in localhost and would not be this. It would be this 3306. And if you have any trouble with that, you can always Google to find out. But if you're gonna do it locally, might as well use the PG admin. Okay, so moving on. Back to Chrome. So if you're developing with a non-relational database, you also use this to deploy, but you can use MongoDB. It's pretty easy to install. You can just Google the site and then install it. It's pretty simple, and you essentially run the server by running MongoDB on like if I just type that into my command prompt, it'll automatically run it. You might have to add it to your path though, to be able to for it to recognize the application. But and then automatically runs on localhost port 27017, and this is where it's stored on my computer. It might be stored somewhere else, like if you had a Mac or something or a different version. Going back to the demo. Here I have, I think I defined it at the top, running this file right here. It's pretty simple. Don't worry about this, but right here, basically what you do is you pip install pymongo and then import OS just for environment variables. But you set up your client once you've run MongoDB in your shell. Use the Mongo client with this as the host and this is the port, and then you can create any database by doing client dot and then whatever database name you want. And so here I've chosen a sort of folder in the database called posts. And so here I have sort of like a sample JSON dictionary with a title, content, and author. And then here I insert the data into the database under posts, and then I save the ID. And so right now, if I run that, just double check everything. So right now it's waiting for me to hit return and continue. But it's basically putting the data in the database, and I'll be able to show you once I use the actual online cluster that it is in the database. But afterwards, I look up the dictionary that I put in with the ID that I saved, and it should be able to print it out. And this is the ID that comes out. This is the whole dictionary. This is the ID, the title that I put in, the content, and me. So now, I set it up with Chrome, basically I go on online to MongoDB, create a free account, and then I build a new cluster and then connect to it. And then this will automatically pop up when you connect, but you whitelist your IP address and create a user, and then it gives you connection information based on what sort of environment you're using. So for me, it basically told me to copy and paste this for Python, but it'll tell you something different if you're using Node or something like that. And I just made my password name, or my password and my cluster name as environment variables. So if I go to Mongo, I sign in. I've already created a cluster, and so I can connect to it. And so here's the step where you basically whitelist your IP address and create a user, which I've done here. Created my user. You can see, basically open it up just to make it easy, but you probably don't want to do that. And then if I go here, connects with my application, and I choose Python, then it'll give me this string to copy, or like this exact line in code that I want to place, or these two lines rather. And so if I view my database, I can actually see the data that's inside. So these are all like the times that I tested it out, posting it here and retrieving it. But I'm going to change it up so that it displays differently. So here, instead of doing it under posts, I'll do it under demo. That should be good. Then I'll run that so that it connects to the cluster. And so now what it's going to do is it's going to post that under the demo database and wait. And so if I go back to Chrome and I refresh, it has popped up, and I can see my post data that I just put in. If I go back to the app, I can resume and retrieve it. So there it displays it again, just like last time. And yeah. And so obviously it's pretty basic and simple. Like you probably wouldn't want to use it as a database if you're just dealing with so little data like that. But when you're developing huge applications, it becomes really nice and easy to manage them. Oh, we do have questions? Oh, okay. The difference between a relational and a non-relational database? Sorry, I missed that. So let me go back a bit and a follow-up question?
Yeah.
Oh, okay. Yes. Um, so relational database uses SQL and non-relational uses NoSQL. And so a relational database is essentially a bunch of strictly organized tables with the possibility of having columns that contain references to other related tables. So here I have a simple entity relationship diagram, and this is sort of like a sample customer table, and it has its primary key, which is the ID. And then it has the related customer ID, which is basically a reference to a customer entity, customer row in the customer table. Um, and then all the other information stored here. And it's pretty strictly defined, like you have to create a migration or a sort of schema in order to use a relational database. So like if I was using it, I'd have to define like, okay, like I want a column for ID, customer, which is a related column, customer name, the street, city, state, zip, ship date. And I don't have it here, but I can also define a many-to-many column for the products under the order. Kane IRL. To answer your question, data for PostgreSQL is actually stored locally on my machine, I believe, on my computer. But when I use MongoDB locally, it's also stored on my computer, I believe. But when I use something like Google Cloud or AWS or MongoDB, those, I guess I could say companies have their own data warehouses where essentially they have a ton of servers that sort of host databases and everything. Yeah, that's good, right? Basically, yeah. To go back, sorry, Steve Kelly. Non-relational, on the other hand, is very loosely defined, where instead of strict tables, it's usually with key value pairs, JSON documents like this, column family stores like this. So JSON is basically a sort of data format where you basically have a key and then it's mapped to a value. And so you can use this, I'll call it dictionary, to look up a value using a certain key. So if I know the key, I can look up the value in the dictionary. And then this is sort of like a table, except it's more loosely defined. You have these columns right here, but they don't exactly match up. And, they can have whatever data they want in them. So like Tori right here has country and hair color, where none of these have it. So it's pretty loosely defined. And then I'd say use case for relational database would be like, so like this customer order product example could be like how Amazon uses databases to serve their website. So they have a bunch of products with their own information in the database, and then when a user adds something to their cart, it automatically creates an order and fills in the information for that and stores it in a database, and like all sorts of information like your address or like the shipping date for like each product, or your credit card information gets stored in there too. And then you as a customer have your own sort of data too. It's probably more user built, so you have your email, your password, all sorts of preferences and information. And then for non-relational, I believe Twitter, I think, probably uses non-relational, where they basically there are dictionaries in the Twitter database for like all the tweets you've tweeted out, or like all the retweets you have. And so like if you actually use Twitter API and you choose certain things that you want to filter, it'll actually return to you a JSON structure with all the information that fulfills your search query. So if you wanna look up like things with this certain hashtag, it'll return to you like a JSON document. And you say like you want 500 results with that certain hashtag, it'll return it to you. So can both these databases be used in conjunction with an app or website? If so, could you briefly describe the software you could use? Sure. I believe you could use them in conjunction if you wanted to. I think you just have to sort of like modulate your application itself. So you'd have to divide it up so that one part of it is using certain settings that connect to your relational database, where another part of it is using other settings to connect to a non-relational database. And if it's easier to split up data like that and you really have to use both of them, then you could, I think. And there's all sorts of software that you can use. Trying to think. Like software in terms of managing the databases. You can do what I did in my demos, where I used Postgres SQL, Google Cloud. You can use AWS. You can use Azure, and then that's for relational mostly. But you can also do non-relational things on AWS. I believe they have their own thing for that. I'm not too sure. And then for non-relational, MongoDB is a good site to use. But in terms of software for like your app or website, like for example, like Django was something that I used for like building a web app, like in my demo, just a simple one. It does pretty much nothing, but Django has all these resources as a framework that you can use to build websites. There's a bunch of other things too, like you can use Flask too to build a web app. But there's a bunch of resources online depending on what you want to do that you can look up. Did I get everything? Thank you, Steve Kelly, for that link. But yeah, if you guys in the chat go to Syracuse University and you'll be around next weekend, sign up for QSACs. And if you look at the link in the chat, or if you sign up for QSACs and you join the Slack, then you can see this presentation and this stream too. Here's all the social media links for QSACs. Here's basically the resources that I used for like database management resources that I used. So Postgres, Google Cloud, and Mongo. And then these are just little things that I used to to make my demos. So like Django has documentation for how to use it, and using Python and MongoDB together with PyMongo or whatever you want to use is in the MongoDB API docs. And if you want to learn more, I briefly mentioned entity relationship diagrams. There's a YouTube video on that. And then differences between SQL and NoSQL. If you want to learn more about that, you can. And I believe that is it. Yeah. Thank you. Should I get the Slack URL and put it in the chat? We'll see. But thank you guys for coming. Thank you guys for tuning in. I hope you learned something today, and I hope I answered all your questions pretty well. But yeah, thank you.